So here we go, question 61, a little bit of differentiation and linear equations. The first thing I'm going to do is draw a little picture, as you might expect. So I'm going to do that by completing the square on the quadratic. X plus 2 squared minus 4 plus 7. So that's x plus 2 squared plus 3. That tells me that the vertex of this quadratic is at the point minus 2, 3. So here's my graph. Minus 2, 3 is there, and the quadratic looks like that. It passes through there at 7, and so when x is minus 1 is about here. So that's the point that we are looking at on the curve. And the normal, we're looking at the normal to that curve there, and that crosses at A and B. So I think that's A and that's B, and this is the triangle we're looking for. So we need to find the coordinates of the points A and B, which means we need to find the equation of this line here. How do we do that? What information do we need to find the equation of a line? We need a point on the line, well, there's the point, and we need the gradient of the line. Okay, so let's set about doing that. Firstly, there's a rather neater version of the diagram. So to find the gradient, I'm going to differentiate. So when I do that, I get 2x plus 4. Substitute the value minus 1 into that to give me the gradient at the point of intersection, and substitute the value of x equals minus 1 into here to find the value of y. That gives me those values there. When x is minus 1, dy dx is 2, and y equals 4. But dy dx is the gradient of the tangent to the curve here. And I want the gradient of the normal, so I'll need to do the negative reciprocal of that. And so the gradient of the normal is minus a half. So here's the gradient of the tangent, so the gradient of the normal is minus a half, and I've got the coordinates of the point on the line. When I put those into the equation y minus y1 equals mx minus x1, I get this equation here, which simplifies to that there. So I'm now close to finding the coordinates of the points A and B. A is where y is 0, B is where x equals 0. So those are the coordinates of B and A. So then half base times height gives me the area of the triangle OAB. So hopefully you got the same answer as I did. If you did, well done.